Introduction. Students, can you tell which equation is this?
This is a linear equation, sir.
Yes, this is a linear equation. Can you solve this equation?
Yes, this is so easy.
Correct. Now tell me which equation is this?
This is also a linear equation.
Yes, this is also a linear equation, but it has two variables, x and y. So it is called linear equation in two variables.
We want to know more about this, sir.
Okay, so we will study linear equations in two variables today. Objectives. At the end of this lesson, you'll be able to define linear equations in two variables, solve linear equations in two variables, find different solutions of the given equation, draw the graph of a linear equation in two variables, represent the solution of the given equation on the number line and on the Cartesian plane. Linear equations. We know that a simple linear equation is an equality between two algebraic expressions involving an unknown value called the variable. The two sides of an equation are called right-hand side or RHS and left-hand side or LHS. Consider this equation. The solution or the root of this equation is -5/2. Let's see where does it represent on the number line. Here it is. Points for solving a linear equation. While solving an equation, you must always keep these points in mind. The solution of a linear equation is not affected when the same number is added to or subtracted from both the sides of the equation. You multiply or divide both the sides of the equation by the same non-zero number. Linear equations in two variables. A linear equation can have more than one variable. Here we'll study about the linear equations in two variables. Let's take an example. Rahul scores 75 marks together in subject Hindi and English. Now, how can we express this information in the form of an equation? Here you can see that the marks of neither of the subject are known. That is, there are two unknown quantities. Let us use x and y to denote them. So, the marks scored in Hindi is x and the marks scored in English is y. So, x plus y is equal to 75 is the required equation. This is an example of linear equation in two variables. Some other examples of linear equations in two variables are 1.2s plus 3t is equal to 5, p plus 4q is equal to 7, and 3 is equal to 2x minus 7y. We can put these equations in the form 1.2s plus 3t minus 5 is equal to 0. P plus 4q minus 7 is 0 and 2x minus 7y minus 3 is 0 respectively. So any equation which can be put in the form ax plus by plus c is equal to 0, where a, b and c are the real numbers and a and b are not both 0, is called a linear equation in two variables. Example. Let's now write these equations in the form ax plus by plus c is equal to 0. The first equation can be written as 2x plus 3y minus 4.37 is equal to 0. Here a is equal to 2, b is equal to 3 and c is equal to minus 4.37. The second equation can be written as x minus 3y minus 4 is equal to 0. Here, a is equal to 1, b is equal to minus 3, and c is equal to minus 4. Now look at this equation. We will write this equation in two variables. This can be written as 1x plus 0y is equal to minus 5, or 1x plus 0y plus 5 is equal to 0. Similarly, the equation y is equal to 2 can be written as 0x plus 1y is equal to 2, or 0x plus 1y minus 2 is equal to 0. Solution of a linear equation. We know that every linear equation in one variable has a unique solution. But how many solutions do the linear equations in two variables have? As there are two variables in the equation, so its solution means a pair of values, one for x and one for y, which satisfy the given equation. Let us take the equation 2x plus 3y is equal to 12. Here x is equal to 3 and y is equal to 2 is a solution because when you substitute x as 3 and y as 2 in the equation above, you find that the answer becomes 12. We can also write this solution as 3, 2, because the value of x here is 3 and the value of y is 2. Similarly, 0, 4 is also a solution for this equation because when you substitute x is equal to 0 and y is equal to 4 in the equation, you find that the answer becomes 12. We have found at least two solutions for this equation. Can you find any other solution? Is 6, 0 also the solution of this equation? Yes, 6, 0 is also the solution, because when you substitute x as 6 and y as 0 in the equation, you find that the answer becomes 12. Similarly, many other solutions can be taken from this single equation, and there is no end to different solutions of a linear equation in two variables. Therefore, we can say that a linear equation in two variables has infinitely many solutions. Example. Let's now find 4 different solutions for this equation. By looking at the equation, we can say that x is equal to 2, y is equal to 2 is a solution because on substituting x as 2 and y as 2, we get the answer 6. Now let us choose x as 0. With this value of x, the given equation reduces to 2y as 6. And substituting y as 3, we get the answer 6. So, x is 0, y is 3 is also a solution for x plus 2y as 6. Similarly, taking y as 0, the given equation reduces to x as 6. So, x is equal to 6, y is equal to 0 is also a solution of this equation. And for the fourth solution, let us take y as 1. The given equation now reduces to x plus 2 is equal to 6, and by substituting x as 4, we get the answer 6. Therefore, 4, 1 is also a solution of the given equation. So, the 4 solutions we get for the given equation are 2, 2, 0, 3, 6, 0, and 4, 1. Graph of linear equations in two variables. Now let us look at the geometric representation of the solution of linear equations in two variables. Look at this table. The solutions of this given equation are expressed in the form of this table. These are the values of x and these are the values of y. Let us now plot these points on a graph paper. Let's first take value x as 0 and y as 3. This is the point we have obtained. Similarly, mark other points on the graph using these values. Now join any of these 2 points and obtain a line. Let us join 0, 3 and 4, 1. Call this as line AB. We can see that the other 2 points, 2, 2 and 6, 0, also lie on the line AB. Now pick another point on this line. Let us pick 8 minus 1. Is this a solution of this equation? Yes, this is, because by substituting the value of x as 8 and y as -1, we get the answer 6. So, 8 minus 1 is a solution. So what we have observed in our previous screen? We have observed that every point whose coordinates satisfy the given equation lies on the line AB. Every point on the line AB gives a solution of the equation. So you can conclude that every point on the line satisfies the equation of the line, and every solution of the equation is a point on the line. This is called the graph of the linear equation. So to obtain the graph of a linear equation in two variables, it is enough to plot 2 points corresponding to 2 solutions and join them by a line. Example. Let us go through an example now. Take the point 1, 2. Now we'll find the equation of a line on which it lies. Since 1, 2 is a solution of a linear equation, so we will look for any line passing through the point 1, 2. One example of such a linear equation is x plus y is equal to 3, because when we put the value of x as 1 and y as 2, we get the answer 3. Other examples are y minus x is equal to 1, y is equal to 2x. In fact, there are infinitely many linear equations which are satisfied by the coordinates of the point 1, 2. Drawing graph. Let us now draw the graph of this equation. X plus y is equal to 7. We know that to draw the graph, we need at least 2 solutions of the equation. So the 2 solutions are x is equal to 0, y is equal to 7, and x is equal to 7, y is equal to 0. We can use this table to draw the graph. These are the values of x and these are the values of y. The point of the values x is equal to 0 and y is equal to 7 is this. And the points for the values x is equal to 7 and y is equal to 0 is this. Now join these 2 points. This is the required graph for the given equation. Equations of lines parallel to the x-axis and y-axis. Answer one question now. Where do the points 2, 0, minus 3, 0, 4, 0, and n0 for any real number n lie in the Cartesian plane? Yes, they all lie on the x-axis, but do you know why? Because on the x-axis, the y-coordinate of each point is 0. In fact, every point on the x-axis is of the form x0. So the equation of the x-axis is given by y as 0. Similarly, the equation of y-axis is given by x as 0. Example. Let's now solve this equation and represent the solutions on the number line and on the Cartesian plane. This equation can also be written as 2x minus x is equal to minus 3 minus 1. By solving this, we get x as minus 4, equation 1. Now let's see where does it lie on the number line. Here it is. Now we know that x is equal to minus 4 can be written as x plus 0y is equal to minus 4. And this becomes linear equation in 2 variables. So the equation reduces to x is equal to minus 4. So we get the first solution of the equation, that is minus 4, 0. Since the value of y will always be 0, so the other solution of the equation is minus 4, 2. Now mark these points on the graph. This is minus 4, 0, and this is minus 4, 2. Join these points. We can see that the graph AB is a line parallel to the y-axis and at a distance of 4 units to the left of it. Did you know The reason that a degree 1 polynomial equation ax plus by plus c is 0 is called a linear equation is that its geometrical representation is a straight line. The graph of the equation of the form y is equal to kx is a line which always passes through the origin. Summary. Let us summarize what we have learned. The equation which is in the form ax plus by plus c is equal to 0 is called a linear equation in two variables, where a, b and c are real numbers such that a and b are not both 0. A linear equation in two variables has infinitely many solutions. The graph of every linear equation in two variables is a straight line. The equation of the y-axis is x is equal to 0, and the equation of the x-axis is y is equal to 0. The graph of x is equal to a is a straight line which is parallel to the y-axis. The graph of y is equal to a is a straight line parallel to the x-axis. An equation of the type y is equal to mx represents a line passing through the origin. Every point on the graph of a linear equation in two variables is a solution of the linear equation.